Okay, today you guys are just going to be looking at a bunch of word problems that tie into transformations. So please, when you start to see like word problems where they give you an equation for a trig function, don't think of it like an algebraic expression. Think of it like a transformed trig function. Okay, so apply the transformations and then apply it to real life. The nice thing about trig is a lot of the things are relatable. So these questions are very similar to the ones you did in grade 11. They're just going to be usually in radians. So I have hints to help you, but basically make sure you know what the variables represent, make sure it makes sense, and apply it back to transformations, okay? The first bullet reminds you to use the function that makes the most sense. Okay, so if your graph starts, like if a cycle starts at the origin, or does it start at a max or a min, that tells you if you should use sine or cosine. So draw a picture. Okay, if you make a sketch, then usually you can figure out which function is easiest to use, depending on what's where at the beginning of a cycle of your graph. If you can use a cosine function without a phase shift, do that. Your textbook will do a sine function with a phase shift. Why? Okay, so do what makes sense in the context of the question. So there's two practice questions here that are similar to textbook questions. I'll run through them. You guys can try them first and then come back, whatever makes you happy. And then hopefully that'll help you a little bit if you're getting stuck. Okay, so the first one, they give you an equation to model the average monthly temperature, and they usually define the unknowns for you. So T, capital T, is degrees Celsius, and then small t is number of months, and 0 is January. Okay, so part A says, what is the period? Rather than trying to think really, really hard about this, just identify your K value, right? Because we know, let's use a pen. We know that our period equals 2 pi over K. In this case, K equals pi by 6. Okay, so I'm going to write it like this. So 2 pi divided by pi over 6, and then you're going to flip and multiply. So you have 2 pi times 6 over pi, and the pi's cancel, and that gives you 12. That makes sense, right? You probably could have gotten to the period using logic, because how many months are in a year? 12, right? So the period is 12 months. So try to put it in the context of the question. Okay, 12 months. So explain it in the context of the problem. Done. When it says, what is the maximum temperature? We know that our axis is at T equals 10. Okay, and we know that our amplitude is 22. Okay, so if I'm thinking about a picture, I have no phase shift. It's a cosine wave that starts at a minimum. So it's like facing down, but my axis is at 10. My amplitude is 22. So that would be 32. This would be negative 12. Okay, so my max temp would be 32 degrees Celsius, and my minimum would be negative 12 degrees Celsius. So I didn't have to do any math. I didn't have to plug anything in. I just had to make that quick little connection between the amplitude and the axis, and life is good. My range of temperatures is from negative 12 to 32, so 44 degrees. Okay, so C, 44 degrees Celsius. And then when it asks for the average temperature in April, that's where we're going to maybe do a little bit of math, right? So for part D, T equals 4, so you can do the math, or you might be able to work from your graph, depending how well you've drawn. Okay, but all that this is asking me to do is this, and we might have to make some connections back to the beginning of the chapter. So pi by 6 times 4 plus 10, negative 22, the cos of 2 pi by 3 plus 10. And remember that we know how to find a value for that, or you can just plop it all into your calculator. I'm just going to hop up here. So 2 pi by 3 is the same as 4 pi by 6. It's over here like that. voila, 2 pi by 3. That means this is pi by 3, and that's pi by 6. So 1, 2, root 3. So my cosine of 2 pi by 3 is negative 1/2. So it's negative 22 times negative 1/2 plus 10. And that would be 11 plus 10 is 21 degrees Celsius. Okay, so there was not a lot of math that had to happen there. And if you draw better than I do, you might have been able to get your answer from the graph because that is a special angle, but probably you want to use some algebra there. But please use those special triangles. That should be habit now. All right, Ferris wheels. So you saw these for sure in grade 11. We'll talk again. Maximum height of a Ferris wheel is 35 meters. The wheel takes 2 minutes to make 1 revolution. Passengers board the Ferris wheel 2 meters above the ground at the bottom of its rotation. Okay, so that means to me, using the diagram over here, from the top to the bottom is 35 meters. But this space here is also 2 meters. Okay, so that helps me figure out stuff about my Ferris wheel. And it's talking about minutes, says use seconds. Okay, so make sure that we actually break this thing down into seconds. So the wheel takes 2 minutes to make 1 revolution, so my period is going to be 120 seconds. My amplitude and my axis, we have to be careful about. So the graph has been shifted up 2. Okay, but so the whole thing is 35. This thing here is 33. So the radius of my Ferris wheel is 33 divided by 2, which is 16.5. Okay, so the amplitude is 16.5 meters, and that has to be 2 meters above the ground. Okay, so we have to be shifted up enough that we're 2 meters above the ground. So my axis would have to be at 18.5 because my minimum has to be at 2. Okay, and then my max is going to be at 33. 35, sorry, 35, there. Okay, so that is kind of 16.5 between each of those, and meets all the criteria of the question. So that's kind of how we're set up. Remember, we're going to board at the bottom. Okay, and then it says to sketch 3 rotations, so I know I'm going to be at 120 seconds, 240 seconds. Hopefully your sketch looks a little better than mine, but like, this is as good as it gets on my little tiny tablet. Okay, so there's my middle. So that is my cruddy little sketch, and that's okay. When you're doing word problems, it doesn't have to be great. It just has to help you answer follow-up questions. Okay, so now we want to write an equation to represent the position of a passenger at t seconds. So the only thing we haven't yet figured out is our k value, right? Because we have no shift, and then we have a, and my axis was at y equals 18.5, so life is good. To get your k value, remember that your period equals 2 pi over k, so k equals 2 pi over 120, which is going to be pi over 60. Okay, and then that's going to go into your equation when you write it. So y equals negative, because we're starting at a bottom, 16.5 cos pi by 60 x plus 18.5. Okay, so that's your equation. And how high is the passenger after 45 seconds? So here's where you just kind of want to start plugging stuff in. The problem is that I have come downstairs with no calculator, but I will try to use my phone as best I can here. Okay, so C, y equals negative 16.5 cos pi by 60 times 45. Actually, that probably works out okay. Plus 18.5. So that's actually just 3 pi by 4. So I can do that. Goes 3 pi over 4 plus 18.5. And then back to those special triangles. That's 3 pi by 4. Cos is negative in the second quadrant. So it's negative 1 over root 2. Up we go. Okay. That I can type in. 0.5 negative times. Okay, so we are at about 30.2 meters. If you type that in right, and if I did it wrong, I blame my calculator. But that's the setup for that. And then part D says the ride lasts for 6 minutes, and then when will the passenger be at maximum height? Okay, so if this is 120 seconds, they're at maximum height at 60 seconds. 180, right? So they're every minute, basically, or every other minute, they're hitting that height. So there's 120 seconds in between. So this would be at 300 seconds and so on. Okay, you would just have to add a period 3 more times. So you're going to add 120 3 more times to get there. Okay, that is how that works for you. So hopefully those refresh your memory a little bit, and then you'll be able to go ahead and do the rest of the problems. Remember, my answers are at the front if you need them.